All right, hello and welcome to another LEAP test video or LEAP practice test video. We are going to jump right in with session one. Session one is, the first half of it is non-calculator. So we're going to try to do this without a calculator. We're just going to jump right in and get started because we know how long it takes Miss Gallant to do a video. All right, so let's start with question one. Let me get this focused too. There we go. All right, so select the word from each list to correctly complete the sentence. The set of all points in a plane that are equidistant from a given point is called a blank. So if we have a given point, and we have a point that's 1 unit away, let's find every point that is 1 unit away. And I'm just kind of doing this. It's not perfect because we know Miss Gallant's not measuring. But if we find every single point, well, it's going to make what shape? It's going to make a circle. Now, we also have sphere, and every point on a sphere is equidistant from a circle, but this is all the points in a plane. A sphere is three-dimensional, so it's not flat, it's not on a plane, it's on multiple planes. So, yeah, so we are going to leave it at circle. That given point right here is called the center. It's not an axis, because that would be a line. It's not a vertex, that would be the point where two lines intersect. And the radius would be the distance between the center and one of those points. So the radius is a segment, the center is a point. Okay, number 2, in the coordinate plane, line P has a slope of 8 and a y-intercept of 5. Line R is the result of dilating a line P by a factor of 3 with a center of 0, 3. What is the slope and y-intercept of line R? Okay, so I have a graph. Line P has a slope of 8 and a y-intercept of 5. So let's go up to 0, 5. 1, 2, 3, 4, 5. And a slope of 8, which means we go up 8 units and over 1. So 1, 2, 3, 4, 5, 6, 7, 8, 1. And 1, 2, 3, 4, 5, 6, 7, 8, 1. And we're going to connect my 3 points. Okay, and I want to dilate it by a scale factor of 3 from the point 0, 3. So this is my center of dilation. Now when I dilate this, basically what's going to happen is every single point on my line is going to dilate. So this point's going to come out here, this point's going to follow this line, this point's going to follow this line, and my slopes are going to be the same. My slope does not change. Basically, when you dilate, all the lines are parallel to the previous. So, that because it's going to be parallel, my slope's not going to change. So what that does is that eliminates anything that's not a slope of 8. Okay? So then we're torn between has a y-intercept of 5 and a y-intercept of 9. So the cheaty way to do this is say, okay, look, I am dilating from 0, 3, which is not, scooch this up, dilating from this point. It's not on my original line, so the y-intercept is going to have to change. So that would automatically get rid of B, leave us with C. I'm going to show you the legitimate way to do this, though, because, you know, they may give you multiple options where you have to select the correct y-intercept. So this is the point 0, 3. This is the point 0, 5. I want to find the distance between 0, 3 and 0, 5. That should be 2 units. Now my scale factor is 3, so I'm going to multiply my distance times 3, which gives me 6. So my new coordinate is going to be 6 units away from the center of dilation as opposed to 2 units away. So, and this actually, I'm off a little, but anyway, so from 0, 3, 6 units away would be 0, 9, which is C. Okay. Haha. Question 3. The equation of a circle. Scooch this up some. All right. So the equation x squared plus y squared minus 4x plus 2y equals b. This is a circle. Now, our standard equation of a circle is x minus h squared plus y minus k squared equals b. I'm sorry, equals radius squared. This is our standard equation of a circle. Excuse this. So we want to turn this into this. The easiest way is to do something called completing the square. So let's get all of our x's together. X squared minus 4x. Then we're going to do plus a box because we're going to complete the square. Plus, we've got y squared plus 2y. And then we're going to add this box. So it's going to be weird. I'm going to add some seemingly random numbers to this so that I can force it into this equation and make it make sense. All right. And then equals b. Now, because I'm adding 2 things to the left side, I need to add those same 2 things to the right side. Okay. So let's figure out what to put in here. Now, notice because I'm going to add stuff to both sides, it's not going to actually change the equation. It's going to remain balanced. So this is not changing my equation. It's just manipulating it so I can figure out, oh, hey, this is where the center is. All right. So again, you see how we have this squared on the outside? We have a squared on the inside. I need to kind of figure out what I can do to get this something squared. So what I'm going to do is I'm going to take this middle term and I'm going to divide it by 2. Negative 4 divided by 2 is negative 2. Then I'm going to square it. Well, negative 2 times itself is 4. Since I'm adding 4 to the left, I'm going to add 4 to the right. We're going to do the same thing here. We're going to cut our middle term in half. That's 1. 1 squared, or x squared, is 1. I'm going to add 1 here. Okay, so what this does is this allows me to figure out what the square root of this is. And basically what I'm doing is the square root of x is x. The square root of 4 is positive or negative 2. Since this is negative, we're going to use negative 2. We're going to use this term that is in the middle. And we get x minus 2 squared. So x minus 2 times x minus 2 gives us x squared minus 4x plus x. So this is an expanded version of this. So this allows me to see what the center is from this. Okay, plus, and do the same thing. Y, this is a positive 1, plus 1, squared. And y plus 1 times y plus 1 gives us y squared plus 2y plus 1. So this is an expanded version of this. Equals b plus, now I added 4 and 1 onto the left. We're going to add 4 and 1 to the right. 4 plus 1 is 5. Okay, and this is the same thing as my r squared in my original equation. So let's look at part A. What is the y coordinate of the center? Well, I'm looking at the y section. I've got a positive 1. Your y coordinate is always the opposite of what's in parentheses. So that's going to be negative 1. Okay, part B, my radius is 7 units. So b plus 5 is the same as my r squared. My radius is 7. So b plus 5 equals 7 squared. 7 squared is 49. I'm going to subtract 5 from each side. B is equal to 44. Now, if this were on the calculator portion, you could pull up Desmos, put B in as a slider, and figure out the center from there. But this was not a calculator question, so we can't do that. Yay! All right. But we are going to move on to part 5. I'm sorry, not part 5, number 4. So number 4, the figure shows triangle ABC is similar to triangle DEF with the side lengths. So we're going to look at our similarity statement. Please trust the information they give you, not just the pictures. Okay, because what I don't want you to do is say DE is similar to BC. We want to make sure we have the correct side lengths. So AB and DE are matched up in our similarity statement. They're the first 2 letters on both triangles. So AB is similar to DE. BC is going to be similar to EF. And AC is going to be similar to DF. All right, AB is 21. BC, we don't know. And AC is 27. DE is 7. EF is 5. And DF is 9. So now we're going to see, since these are similar, there should be a scale factor between these. So 21 to 7, I can divide those and get 3. 27 to 9, I can divide those and get 3. And x divided by 5 should give me 3. So 3 times 5 is 15. Okay. All right, let's look at number 5. Number 5 is a proof. Everybody loves proofs. Okay, in the figure shown, so we have our figure and we're going to use it for both proofs. Line CF intersects AD and EH at points B and F respectively. Given that CBD is congruent to BFE, prove that ABF is congruent to BFE. So we want to prove that all 3 of these are congruent. Okay, CBD is congruent to BFE. Why? Well, if we look at our given, that matches, so that is given to us. Okay. Statement 2, CBD is congruent to ABF. So CBD is congruent to ABF. So these 2 angles are congruent. Why is that? Well, let's look at what kind of angles they are. They are directly across from each other. So that's the definition of a vertical angle, and vertical angles are congruent. Okay. And then our last statement, ABF is congruent to BFE, which is what we're proving. Notice the word prove is not on here because prove is never an answer. It is never a reason. Every time you write the word prove down, a puppy dies. Don't get me fired. All right, we want to know why ABF and BFE are congruent. So let's look at this. We said CBF and BFE are congruent. I'm sorry, CBD and BFE are congruent. CBD is also congruent to ABF. So these are both equal to the same thing. Okay, so it's like if I go to McDonald's and I have $5, a large fry could cost $5 and a soda could cost $5. And I'm just making this up, okay? If they both are equal to $5, that means they are both the same value. They are equal to each other. So I could trade in fries for a soda. And that's not a great example, but it kind of makes sense. So I could say that these two are congruent by transitive property. I'm trading in that CBD for ABF. It's kind of like substitution, but it's with two equal statements. So this is the transitive property of congruence. Okay. All right, and that is completed. All right, so let's look at part B. Given that the measure of CBD and the measure of BFE are equal, so CBD and BFE are equal, so I'm going to do this in pink. So given that these two are equal, prove that BFE plus DBF equals 180. So we want to prove that if I add these two, it'll equal 180. Okay, so first statement, measure of CBD is equal to measure of BFE. Why is that? Well, that is our given. Measure of angle 2, CBD plus DBF is equal to 180. So CBD and DBF. So if we look, a lot of people, let's look at what we know about these angles. They share a side, so they are adjacent. The sides they don't share, though, form a line, so they're a linear pair. So it's got to be one of these two. It's either that linear pairs are supplementary or adjacent angles are supplementary. So let's look at this. Adjacent angles just have to share a side. So these are two adjacent angles, but they're not supplementary. Their total does not add to 180. Whereas the angles in our diagram did this. They formed a line. So whatever this angle and this angle are adds to 180 degrees because it forms one line. That is a linear pair. So angles that form a linear pair are supplementary. Okay. All right, and the final statement, measure of angle BFE plus the measure of angle DBF equals 180 degrees. Why? So I can't use transitive property here because it's not these two are equal, so these things are equal. So it's not transitive like it was last time. Now if I look from this to this, the only difference is I took CBD and changed it to BFE. That is substitution. It's similar to transitive, but transitive, it's just that A is equal to B, B is equal to C, so A and C have to be equal. Whereas substitution, I'm literally taking, oh, these things are equal, so I can just replace it. It's very similar, but not quite the same. So this is going to be substitution property of equality. All right. All right, and this brings us to number 6. Number 6, point Q lies on ST, where ST is located at -2, -6. Point T is located at 5, 8. If the ratio of SQ to ST is 5 to 2, where is point Q on ST? Plot out point Q on the coordinate grid. Okay, so the ratio is 5 to 2. So that means that from S to Q is 5x, and from Q to T is 2x. Okay, so we have 5x to 2x. Now, what is the total length of S to T? That's going to be 7 times whatever my scale factor is, or 7x. So, SQ is 5/7 of ST. And so we could find the distance from S to T. We could use the distance formula. That's kind of a pain in the butt, though. So why don't we instead get a vertical distance and a horizontal distance? Okay? So from S to T vertically is 14 units. From S to T horizontally is 7 units. So if I want to break this up in a ratio of 5 to 2, out of 7, that would be 1, 2, 3, 4, 5, and 1, 2. So that would be at 3 on the x-axis. That intersects my line here at 3, 4. Now let's just double check going horizontally. That does the same thing. So 14 units, 5/7 of 14. We're going to reduce this. 7 goes into 14 2 times. 5 times 2 is 10. So let's count 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that puts me at 4. And that does intersect my line. So what that does is that puts SQ as 5/7 of this line and QT as 2/7 of this line. So point Q has the coordinates 3, 4. Okay, let's look at 7. Now, number 7, we have a circle. It is divided into sectors. From E to B is the diameter. The radius of F is 3 units. We want to complete the table by writing each arc length next to its central angle. So let's look at this. Angle AFB is 120 degrees. Now, let me double check. I don't believe, no, we are still in the no calculator portion, okay? So we have to be very careful with this. We have 120 degrees. Now, to get my degrees to radians, we multiply by pi and divide by 180. Okay, this is going to be hard to do without a count. Well, maybe not. Let's do this. Let's reduce this. 12 out of 18. I can divide both of those by 6, and that leaves me with 2 and 3. So that would be 2 pi over 3, which I don't see in my answer choices. But my radius is 3, so we're going to multiply this by my radius. These are for a radius of 1, so we're going to multiply by my radius. Times 3 divides by 3 cancels, and we're left with just 2 pi. Okay, BFC, B to F to C, so that's 45 degrees. We're going to do the same thing. 45 degrees times pi divided by 180. Okay, so I believe 45 will go into 180 4 times, because 45 is half of 90 and 90 is half of 180, so that goes in 4 times. So that leaves me with pi over 4 times my radius 3 is 3 pi over 4. Okay. All right, so let's look at this too. 120 degrees, that is my longest arc on here. My largest arc length is 2 pi. My smallest arc is CFD, 30 degrees. My smallest arc length is half of pi. Okay, and then this leaves me with just pi. So you can continue to do this, or you can use some logic and go, okay, this is my longest, this is my next longest, this is my next shortest, this is my shortest. And use a little bit of logic. Logic is math reasoning. I'm never going to be upset with you for using your brain. Okay, number 8. Let me get a graph paper. Let's do this one. All right. Okay, triangle ABCs has vertices A at 1, 2, B at 4, 2, 3, 4, 1, 2, 3, 4, 5, 6, and at 4, 4, 2. Okay, so it makes a right triangle. So this is A, B, and C. All right, and then I've also got some patty paper here that I'm going to trace. Hopefully it doesn't smear everywhere. Okay, we want to reflect this over the x-axis. So we want to take this and flip it over the x-axis. Okay? Then we want to rotate it 180 degrees about the origin. So rotating it like this is 90 degrees. And rotating this way is 180 degrees. So it basically looks like we just reflected it. So it should look like this, with this being A prime, this being B prime, and this being C prime. Okay, so then it's just, we're going to figure out the coordinates of the vertices. So this is A, over here is A prime is at -1, 2. So this is at +1, this is -1, -2, -1, 2, +1, 2. So our answer should be C. Okay, number 9 is in the constructive response videos. So I'm going to skip number 9. You can find that in the constructive response video section. This video is already getting lengthy. I felt like that would have been asking a lot of y'all that would have been like an hour long to do all of that. So we're going to move on to number 10. Number 10, the right triangle in the coordinate plane is rotated 270 degrees clockwise. This is too small of a right triangle, so let's do this. Okay, so let's draw our right triangle. I am going to put my coordinate down. Okay. Oh, and it is rotated 270 degrees clockwise about the point 2, 1, which is where where A is. So we're going to rotate it clockwise 270 degrees around A. So this is 90, 180, and 270. Okay? And then we're going to reflect it across the y-axis. So here's my y-axis. I'm going to go all the way down to the origin. I'm going to reflect it over, make sure it goes all the way down to the origin. Here is my new coordinates. So let's see. We've got a point here, right here, and right here. Okay, so this is our new coordinates. And remember, you will have patty paper on the test. I lost my straight edge somehow. Oh, no, I just can't see it. Okay, this would be A prime, this would be B prime, and this would be C prime. All right. And then number 11, each of the two-dimensional figures shown will be rotated 360 degrees about the respective line, creating a three-dimensional figure. Draw the line from the appropriate two-dimensional figure to identify the correct representation of the resulting three-dimensional figure. Okay. So first thing we're going to do is play one of these things doesn't belong. If we look, this one has a hole in the center. Okay? All of these are solid. If we look at these, all of these are touching an axis. This one is not. So if I were to rotate this all the way around this, like let's just say it's a circle rotating around a pencil or something. If you were to rotate this, it's going to make this donut shape. It's not touching the center, so it's not going to fill in that center. We're going to be left with a hole. So this matches with this. Easy peasy. All right, so then if we were to spin this around to create a three-dimensional figure, it's a circle. It should leave us with a sphere. My triangle, if we were to spin this around, it should make a cone, leaving my rectangle to make a cylinder. I always tell people, like with the cylinder, think about a roll of paper towels. When you pull your paper towel out, it's a rectangle, but when you roll it up, it makes a cylinder. Okay. All right, so from here, we are left with question 12, which is a constructive response, question 13, which is a constructive response, and then we are on to question 14, which is in session 2. So I'm going to leave you here with this video. Thank you so much for coming and seeking this out. I hope you guys have a great day, and session 2 should be up tomorrow. Have a good one.